Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 11, Cosmic Expansion. You continue following signs for hot springs and eventually you come across an observatory. The elf within turns out to be a researcher, studying cosmic expansion using the giant telescope there. He doesn't know anything about the missing machine parts, he only is visiting this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observations and analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image, your puzzle input. The image includes empty space and galaxies. The researcher is trying to figure out the sum of the lengths of the shortest parts between every pair of galaxies. However, there is a catch. The universe expanded in time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands in fact. The result is that any row or column that contain no galaxies should all event actually be twice as big. In the example above, 3 columns and 2 rows contain no galaxies. These columns need to be twice as big, the result of the cosmic expansion, and therefore it looks like this. Equipped with the expanded universe, the shortest part between every pair of galaxies can be found. And yeah, so it's 36 pairs of galaxies. And then you need to figure out all the paths between them. Now we have a galaxy list. And for each line, there we go. For each string character. Line split again. And then we do x plus plus. X needs to be 0. Y plus plus. If the current character is equal to a hash mark, we have a galaxy. So the galaxy list needs to add a new galaxy with x and y coordinates. Create that constructor. Private int x. Final plan. No, not the final. We need to expand this universe, so final is not an option. This x equals x, this y equals to y. So we have the same kind of like C size 10 y list new int galaxy size and then x list galaxy size. So what we do then, instead of counting galaxies, is that when we find this, we will take y list y plus plus x list x plus plus. So now we should have a couple of these lists that are 0. Now we can expand the universe. Galaxy 4, Galaxy, Galaxy list, G expand with X list and Y list. That is equal to 0. X inc. And this X is larger than X. Then X inc plus plus. And the same goes for all the Y inc. This X plus equals to X inc. This Y plus equal to Y inc. So now we should have the expanded universe after this. Go through each of them and figure out the length. So if we go from 0 to Galaxy list size, like that, and then we do the same for again, but with J, which starts at I. So now we should be able to get the length. Galaxy list get I length to Galaxy list get J. And the length 2 is this X minus Galaxy X, and we need the absolute value of that. X diff, and we need a Y diff. And we will return X diff plus Y diff. I think this is the Manhattan distance calculation. And if we run that, we get a value of 374. And the value should be 374. So that was correct. Now let's go over here and run the full example. And it has a Galaxy 140 size. We get this huge number. Put that in. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. This video series is sponsored, so for all your hosting needs, go to DigitalOcean.
If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description.
So let's check part 2. The galaxies are much older and thus much farther apart than we initially estimated. Now, instead of expansion you did before, make each empty row or column 1,000,000 times larger. That is, each empty row should be replaced with 1,000,000 empty rows, and each empty column should be replaced with 1,000,000 empty columns. In this example above, if each of the empty row and columns were merely 10 times larger, the sum of the shortest part between the pair of the galaxies should be, if each row were 100 times, the sum should be between every pair of galaxies would be. However, the universe will be needed to expand it far beyond these values. Okay. So it's pretty much just add to this galaxy expansion part here. So let's go back here. And we only have for 10 and 100. So let's try those just to see that this works. So we get back here, we run this, we have 374, and here we will increase this by 10. That didn't work. If we have 1, and we should add 9 then, right? Is that the correct assumption? Yes. Then we get 130. And if we add 99, yes. So what we want to do now is figure out a way to add that value. It worked for that size, but I'm pretty sure it will not work for the larger size, because this will be much larger. Probably x and y could be integers still, maybe, but let's see. We get this size, which is huge. So let's try it. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So the hard part there were pretty much, if you expand it and add these many, you just need to decrease with 1. So instead of adding 1,000,000, you need to add 999,999. So let's look at the code. Today's example were that we had a galaxy, which we had hash marks for galaxies. We created a galaxy list. And then we had an XY value, and we also had an XY list where the actual galaxies were. And then we went through and mapped out all the galaxies, added them to a list. We added them also to these two lists where the galaxies actually were in XY positions. And then we expanded the galaxy with these X and Y lists. And the expand function is pretty much we figure out how many increments we need to do to the galaxies. So we go through this length list here, and if we have a 0, so there is no galaxies in the X coordinate size, and this particular galaxy is further away in the x values, then we need to increment this particular galaxy's value. And the same goes for the y value. We also need to increment that. And then we times that on how many rows we need to add to expand the value, the galaxy. After we have expanded the galaxy, we will go through a list of all the galaxies from 0 to the size of it, and then we will go through a smaller subset which starts at the galaxy we compare with until the galaxy list. And we will compare each and every one of them and see how far they are apart. I believe that we actually would need to do +1 here, but there is a 0 length between itself and itself, so it doesn't really matter. And then we add that up to this value and we print that out. So today was not that complicated. It was a fairly straightforward thing to solve today. And this was this video. I hope that you like it. Share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you want to share your own solution or talk about this day, please leave a comment in the comment section down below. And I really hope to see you in the next video.